Hey everyone, welcome to IBDP MAI HLSL course. You can find all the topics in this playlist. Okay, so this is the first video in this course. Let's start with SL 1.1, which is writing the number in the standard form or operations with the number to represent them in a times 10 raised to the power k, where a is a number which lies between 1 to 10 and k is always an integer. Okay, like if your calculator shows you 5.2 E30. You cannot write your answer like this in your exam. It's not acceptable. You have to change it to 5.2 times 10 raised to the power 30. Okay, so remember this. Now in this session, I will teach you how to move the decimal to the right direction or the left direction, or how to represent your number in this standard form whenever required. Even in your calculator, there is a function that can give you this scientific notation, standard notation, engineering notation, and everything. Okay, but if you are not using GDC, then also you can solve these questions. Okay, so let's start with the problem. This one, it says Neptune is located 4.3514 times 10 to the power 9 kilometers from the Earth. Now it says write this number as the decimal. So this time this number is already given in the standard form, right? This is the standard form here. This number is the A, and yes, it is lying between 1 to 10, correct? Times 10 raised to the power k. Here k is 9. Now, this is find the decimal representation for this. This time the power 9 is a positive integer. So in these cases, it means you are multiplying with 1 then 90, right? So in order to do so, you need to shift this decimal. Right now it is 4.315, sorry, 4.3514, okay, times 10 to the power 9. So you need to move your decimal 9 places to the right. Okay, so already we have 4 digits, 3514 here. So we need 5 more places to go where we can take zeros for that. So I hope you got this. We need to multiply this number with 10 raised to the power 9. In order to do so, we will shift this decimal to 9 places, right? And we can put zeros over there. So we will get 4, 3, 5, 1, 4, then 5 zeros. That's the answer. That's the decimal representation. Now the second part. It says Nicole reads the number 8.03 e raised to the negative 5 from her GDC. Write down this number in the standard form, then express it as decimal number. So now we will write its standard form. As I said earlier also, you cannot write your answer like this in the exam. You have to write it as 8.03 times 10 raised to the negative 5, right? So let's write the answer like this. Now it also says express your answer as the decimal. So this time we have negative 5 power. It means we need to shift this decimal 5 places to the left. How many digits we have, by the way, here? Only one digit we have in the left side. So remaining digits will be zeros, right? So all you have to do is you need 4 more zeros. So you will get 0, 0, 0, 4 zeros. Then you will have this 803, and you have to shift your decimal to this point, right? And before this, what we have? We have obviously 0. So its value will be 0.0000803. All right, this much. Now the third part. It says 1 grain of pollen weighs this much milligrams. Write down the weight in the standard form. So this time it's already in the decimal representation. We need to write it in standard form, which is, for that we need a and power, right? So we have these 2 and 5, as you can see. So our answer will be 2.5, 2.5. That's the a value. Now we need to write it 10 raised to the power something. So obviously we need to shift this decimal to the right. How many powers do we have here? Now let's count the digits. So we have 1, 2, 3, 4, 5 zeros. After that, sixth number is this 2, right? So that's it. From here we can say the answer will be 10 raised to the power of negative 6 in there. So 2.5 times 10 raised to power negative 6 is the standard form representation for that number. Okay, so in this way you can shift the decimal, you can write in the standard form. Okay, now the next part. D says one astronomical unit is this much kilometers. Okay, we need this value later. Astronomical unit. Now, the Voyager 1 spacecraft reaches a distance of 141 astronomical units from the Earth by the year 1998. Write this distance in kilometers in the standard form. So we have this much distance in the kilometer, right? And 141 astronomical unit is the total distance. And one astronomical unit is this much kilometer. So in order to find the total distance, what we can do, we can simply multiply this number with this number. Correct? And we will get our answer in kilometers. But later we have to convert it in standard form also. So let me write it for you. When you multiply 141 astronomical units with this, what is the value of astronomical units? This one. So multiply this. You can use any calculator. You can use GDC that can directly give you the answer. But okay, let's use a normal calculator and we get the answer like this. Now we need to write it in the standard form. So you have to, what you can do, 2.1, as you can see, we have to write it like 2.1093 something. Then we have some 10 raised to the power. Now let's find what power we have here. So for that you need to count the number of digits. So how many digits these are? So take that power of 10 and 2.1093 and so on will be the value. So in this way you can write it as 2.10933318 times 10 raised to the power 10 because these are 10 digits here. Okay, so this much kilometers. This is the standard form over here and that was the decimal representation. Standard form. Now the last part. It says hence justify the estimate that the Voyager 1 spacecraft reaches approximately 5 times as far as the Earth as the Neptune by 1998. So this time we already have this distance, this much distance in kilometers. But what it says, Neptune is located at 4.3514 times 10 raised to the power 9 kilometer, right? So what we can do, we can, in order to find the ratio, we have to divide these two numbers and later we have to convert it in the standard form. So we already have these two numbers. So this is the distance of the Neptune to the Earth and this much we already calculated. This much is the distance traveled by that Voyager 1 spacecraft. Okay. Now let's divide these two numbers. So we have 2 point this 1093,318 times 10 raised to the power 10 whole divided by 4.3514 times 10 raised to the power 9. If you use your GDC, you can directly get your answer almost 5. It's close, very close to 5. But if we are solving it with hand, so what we can do, this 2.10933 something is almost 2. So in place of writing it like this, we can also say 2. And 4.3514, we can consider this as almost 4. Okay. So we can again rewrite our answer as 2 times 10 raised to the power 10 divided by 4 times 10 raised to the power 9. There is a difference in the powers, right? Here we have power 10. So what we can do? We can write it as 10 times 10 to the power 9. And 2 times 10 can be rewritten as 20. So let's change it. So we get 20 times 10 raised to the power 9 upon 4 times 10 raised to the power 9. Cancel out these powers. 4 times 5. 4 times, right? 5 is 20. So we get the ratio as 5. And that's the answer. Hence the proof. Okay. So we are just approximating things. Now, later in the same course, we will discuss how to estimate the value or how to find the errors, percentage error, significant figures. Okay. Next one. You are given the following information. The number of cells in the human body is 37.2 trillions and 1 trillion is this much. Later it says average length of the cell is this much nanometers and 1 nanometer is 10 to the power negative 9 meters. Okay, so conversion is already given to us. The first part says write down the number in the number of cells in the human body and the average length of the cell in the standard form, both. So first we will convert this and then this in the standard form. So let's find these values. So 37.2 trillion cells are there. So 1 trillion is this much. So if I multiply these two numbers, I will get total number of cells. So let's find it. So 37.2 when multiplied with 1 trillion gives me this much number. But in order to write it in the standard form, first I need to count the number of zeros here. So as you can see, 3, 6, 9, 12. And here I have 37.2, but we need to write it as 3.72, right? 3.72 times 10 gives me 37.2, and from here I already have 10 to the power 12. So what can I write here? Yes, I can write it as 37.2 times 10 to the power 12, further can be rewritten as 3.72 times 10 raised to the power 13. Okay, and that's my answer for the first part. Similarly, for 1000, 10,000 nanometers. Nanometer is what? 10 to the power 9. So we can multiply these two also. So we have 10,000 multiplied by 10 to the power 9. This 10,000 is nothing but 10 to the power plus 4 multiplied by 10 to the power negative 9. Base are same, powers gets added up. So here I will get 10 raised to the power 4, powers get added. So 4 plus of minus 9 gives 4 minus 9. That comes out as 10 raised to the power negative 5. So that's the value. Okay. Now we got the standard form of total number of cells and this average length of the cell. In the B part, it says calculate the length of if all the cells are placed in a straight line. Okay, so if all the cells are placed in a line, what will be the final length? So we already have the length of one cell and we also have how many cells are there. So these many cells having length this much each. So if I multiply these two, yes, I can get the total length if they are placed in a straight line. So let's find this value by multiplying these. So 3.72 times 10 to the power 13 multiplied by this 1 times 10 raised to power negative 5 meters. Now powers. Look at the powers. Power is what? 13. Power is negative 5. So when these two gets multiplied, powers gets added up. 13 minus 5 gives 10 to the power 8. After that, 3.72 stays as it is because this is 1. There is no effect on that. So can I write it as 3.72 times 10 to the power 8? And that's my answer in meters. Always write the units also. Okay. And try to write your answer in three significant figures. We will discuss these things later, by the way. But yes, in this way, you can convert standard form to decimal, decimal to standard. You can perform these laws of exponents, right? Now, it also says find the answer in the kilometer. And we know 1 kilometer is what? 1000 meters. So in order to find that, we can simply divide that number 3.72 times 10 raised to the power 8 divided by 1000, right? So that much meter is kilometers for 1 kilometer. So what is that? 10 to the power 3 here. Now, using laws of exponent, I can say 10 raised to the power 8 minus 10 raised to the power 3 gives 10 raised to the power 5. That's the final value for this. Okay. Now, next problem. It says evaluate 3 times 10 raised to the power 40 whole squared minus 5 times 10 raised to the power 80. You can pause the video and try these questions also by yourself. So now here I'm providing this solution. Using the laws of exponent, if you have 8b whole raised to the power something m, so you can write it as a to the power m, b to the power m. So here 3 times 10 to the power 40 whole squared will become 3 raised to the power 2 times 10 raised to the power 40 whole squared. So that is 2 times 40 minus 5 times 10 raised to the 80 stays as it is. This 3 squared is what? 9 times 10 to the power 80 minus 5 times 10 to the power 80. Now base, you can take out this 10 to the power 8 common. If you take out 10 to the power 80 common, you are left with 9 minus 5. Either you can use your GDC, then also you can get the answer. But if you are solving it manually, 9 times 10 is 9 minus 5 times 10 is to the power 80, which is nothing but 4 times 10 to the power 80 is the final value. Second part, evaluate 3 times 10 to the power n plus 1 minus 4 times 10 to the power n. Now we have to write our answer in the standard form. This time, as you can see, there is some power in n and you cannot use GDC for this part, right? So, okay, let's do it manually. So, here 10 to the power what? N plus 1 is there. This part have 10 to the power n. So, let's make the same powers of 10. So, can I write it as 3 times 10 times 10 to the power 9? Rest of the things stays as it is, 4 times 10 to the power n. What is that? 30 times 10 to the power n minus 4 times 10 to the power n, which can be simplified by taking out 10 to the power n common, and you are left with 30 in the first term minus 4 in the second term. So what we have? We got 26 times 10 to the power n. But is this the standard form? No, it's not the standard form because this number a is 26. We cannot leave our answer like this if this says write the answer in the standard form. It means we need to write it as 2.6. So what we are doing? We are multiply. We have to take care of the powers of 10 also. We are moving this decimal one place to the left. So that can be rewritten as this. This is 26, right? Now the final answer is going to be 2.6 times 10 raised to the n plus 1. Powers gets added. 10 times 10 raised to the power n. Base are same. Powers gets added up. Next, this one. So you can try this question by the way all by yourself. It says 6 times 10 to the power 9 n divided by 8 times 10 raised to the power minus n. And again, you have to leave your answer in terms of this standard form, a times 10 raised to the power k. Okay, so I'm giving you this question as homework. Try this question all by yourself. Write down the answer in the comment box, and if you have any other doubt, you can ask me in the comment box also. Now, in this session, we have covered everything required for this SL 1.1. You can watch the other sessions or other videos to cover this whole course. Input and interpret numbers of the form in the calculator. Factorizing, add, subtract, and writing it in the standard form. We already covered this part. And using the laws of exponent if numbers are in multiplication or division also. Okay. So that's it for this session. Thank you for watching this. See you in the next part. You can also contact us on the given details. Thank you.